The formula for the volume of a pyramid starts off very similar to the formula for the volume of a prism. You start with the area of the base times the height. And again, the base and the height are perpendicular. But instead of just keeping this, you are also going to multiply by 1/3. So 1/3 times the area of the base times the height. So let's try a few examples. Our first example, we have a triangular pyramid. So this triangle down here is the base of the pyramid. So we can see that one side, one leg of this triangle is 3 centimeters long, and the other leg, which is perpendicular to it, is 4 centimeters long. And this leg, the hypotenuse, is 5 centimeters. But remember, when we're finding the area of a triangle, we need to do base times height divided by 2. And the base and the height are perpendicular to each other. So that means that we want to use these two sides, the one that's 3 centimeters long and the one that's 4 centimeters long, as the two sides that we multiply together because they're perpendicular. So we would take 3 times 4 and divide it by 2. 3 times 4 is 12, divided by 2 is 6. So this is the area of the triangular base, which we would say is capital B. So when we want to find the volume of the pyramid, this is 1/3 times the area of the base times the height, which is 1/3 times the area of the base, which we said was 6 square centimeters. And then the height has to be this red dotted line here, because this is what's perpendicular to the base, the triangular base. So the 6 right here, this is the height of the pyramid. So we're going to multiply by another 6. So the volume in this case, 1/3 times 6 is 2, times 6 is 12. So our volume is 12 and our label would be centimeters cubed. For the next one, we have a base that is a square, right? This side here is 3, this side is 3. They're congruent to each other so that these sides are also 3. So that means we would have a square. So the square pyramid, again, we find the same way. The volume is 1/3 times the area of the base times the height. Well, let's first find the area of the base. The area of the base is square. We would take 3 times 3, or 3 squared, which is 9. So our volume would be 1/3 times 9. And then the height of the pyramid, we can see that this is 5 units, and this is perpendicular to that the base. So 1/3 times 9 is 3, times 5, our volume would be 15 units cubed. The last one is a little bit more challenging. Here we can see that we have a hexagonal base. And for the hexagon, I can see that all sides of the hexagon are congruent and all angles are marked congruent, which means that we have a regular hexagon. And when you're looking at a regular hexagon, it's actually made up of equilateral triangles. So if you put a center right, or a point right at the center, you can connect that point to all of the different vertices, and all of these triangles here are going to be equilateral. So if I need to figure out the area of the base for capital B, the easiest way to do that is to find the area of one of these equilateral triangles, for instance, and then multiply it by 6 because there are 6 of them. So let's focus on just one of those triangles. So if I kind of draw this triangle in right here, let's find the area of that triangle. So the area of the triangle, remember, is base times height divided by 2. So in this case, all of these along the side, all of the sides of the hexagon are 11. So this is 11 centimeters long, and then it tells us that this height of that triangle is 9.5, or not centimeters, kilometers. Sorry, I don't remember if I said that or not. 11 times 9.5 divided by 2. And that's going to give us just one of these triangles. So 11 times 9.5 and then divided by 2, that means one of these triangles is 52.25 square kilometers. Since there are 6 of them, we want to multiply it by 6, and that's going to give us the area of the base. So the area of the base, if we take that amount and multiply by 6, we're going to get 313.5. So 313.5 kilometers squared, that's going to be the area of the base. So again, first we found this triangle, and then we can see that there are 6 of them in this hexagon. So our volume of the hexagonal pyramid is 1/3 times the area of the base times the height. So it's going to be 1/3 times 313.5 for the area of the base. And then we can see that this line segment right here is perpendicular to the base. It is 12 kilometers long, so that is the height. And if we use our calculators, we would get that this is equal to 1,254 cubic kilometers. And that would be our volume of the entire pyramid.